So hi guys, how are you? Hope all are you doing well as the coronavirus is going on. So in the last class we have seen if we keep a charge on the vertex of a cone, then the flux leaking out of that cone will be how much? The q upon 2 epsilon into 1 minus cos theta, where theta is the angle of the cone, right? So now we are going to see the different application of the Gauss law. Actually, we have to find out the field of the different geometries. So any 3D object can be of conducting and non-conducting. The conducting materials are the materials which are having the charge only at the outer surface, not inside the body. But the non-conducting bodies have the charge inside the bodies, right? So now, so if any body is there, right? So there is conducting and one is non-conducting, right? Okay. So here we will see the hollow. Here we will see solid also. But here it the non-conducting but hollow. This body will behave the same of conducting in case of field. In non-conducting we will see only solid, right? Okay, so first we'll take these cases: conducting, hollow, solid, and non-conducting, hollow, right? Okay, now we are going to find out the field of solid, conducting, okay, and hollow, conducting, and hollow, non-conducting, right? Now, so the field out of this solid conducting, hollow so conducting, and hollow non-conducting are same. So let's take example of a let's take an example of the cylinder, right? Okay. So this is having a this is a cylinder of radius r and length L, right? So we have to find out the field of this. First we will find out outside, right? We will see the field outside. So it means we will take a random point somewhere at point at radius r, smaller. Let's take this point. We have to find out the field here, EP, the field at the point P. So how will we find that point? With the help of Gauss law, what we'll do now? So we'll create an external cylinder. Means some imaginary cylinder we'll create, right? We'll create some imaginary cylinder. So this cylinder will be what? Let's suppose the radius is r, okay, and length, let us suppose L, small l, okay. So we know that the flux leaking out of this outer surface, this imaginary surface, will be how much? By the Gauss law we can say Q by epsilon, right? If it is the vacuum, it is epsilon naught. Okay, now so we know that the flux leaking out of this surface will be Q by epsilon, and we know one thing more. If this flux is there, I mean this area is there, so area vector will be here, right? Okay, so area vector will be here. Suppose some charge is there, so where will be the charge? As it is solid conducting or hollow conducting or hollow non-conducting device. So surface the charge is only at the surface, okay. So it is equal to E dot A also. Which area will take? This area of the imaginary circle which we created around the original geometry. Now E, so we know that We are not considering all the cylinder. We are considering only this cylinder. Why? Because we have made the cylinder up to this height. Okay, the imaginary cylinder we made up to this height only. That's why we will take only this charge, the charge inside this, right? So if you take it out, it will become like this. So small length and radius, it will be r. It is the origin. We have taken the origin. So the area will become, this area is different and this area is different. This area is of this and this area is of this one, right? So area will become 2 pi r l, right? If the charge is outside the surface, so we can say the charge will be how much? Sigma into A. What is sigma? Sigma is what? Areal charge density. What? Areal charge density. What is areal charge density? Suppose we have some area like this. Let us suppose 5 meters square area we have. If you have 5 meters square area and the charge of this total sheet is how much? 10 coulombs. Okay. So what should be the, if I cut 1 meter square area, what should be the charge? So for 1 meter square area, the charge will be 10 by 5. That is 2 coulombs per meter square. It means if I cut a sheet of 1 meter square, I will get a 2 coulombs of charges. It means the linear charge density, areal charge density of this particular sheet is 2 coulomb per meter square. In the same way, if we got this area, sigma A, so what is the charge here? Sigma 2 pi r l, right? Okay, now. And if you take this one, so what is this area? This area will be 2 pi and this one outer is r and small l, right? So now here phi equal to q. Q is how much? Q is how much? Now Q is sigma 2 pi r l, right? Upon epsilon is equal to, what is the field of this charge? So we know that the field generated at any point, see, if we have any charge Q, right? We want to find out the field at this point P, which is r distance away. So Q is what? So the field will be kq by r square, or we can say it is 1 upon 4 pi epsilon q by r square, right? Both are same thing. So now for field we write k q by r square into a field. We have to find out the field, or we have to find out the field. So field is what? So now we will not use it because we want to find out field only, right? So field is A. What is the area now? It is this area will take, because this is for the flux leaking out of this imaginary cylinder. So it is 2 pi r, right? Okay. So 2 pi and 2 pi will be cancelled. So we will having now sigma by epsilon by r into capital R, because L also will be cancelled. Okay. Now, so we will having the A is equal to sigma r by epsilon naught into r. So as we know, this is constant for any material, and this is also constant as we have taken the original body, the radius r, and the epsilon is also constant. So we can say the A is proportional to 2, inversely proportional to the r. It means as we move away from the cylinder, so the field will decrease, right? So now what we'll do, we'll find out the inside field. Inside, we will find inside. Okay, so it is r radius and the length L. Okay, now we know that phi is equal to q by epsilon naught equal to EA. We are finding out at any point inside, any point we are taking here. But we know that charge is only outside, not inside. So we can say Q is equal to 0. When the Q is equal to 0, we can say the phi equal to 0 by epsilon into EA, right? So E here is equal to 0. It means the field at any point will become 0, correct? So if you want to make the graph, how can we make the graph? Let's take the cylinder on the y-axis, and it means the field we will take on the y-axis and the radius we will take at the x-axis. So it means it is the inside point, right? Inside, up to this point, field is 0, right? Field is 0. It is inside. And if we move at this point, what should be the field? Field will be, keep the value here, R is equal to capital R. R equal to capital R, it will be sigma by epsilon. But as we move away like this, in place here, in place of small r, you can keep the R, so it will be sigma by epsilon. That is by the Gauss law, right? So now we know that it is inversely proportional to R, right? So this is how the field will be vary for the cylinder, which is for solid conducting, hollow conducting, and hollow non-conducting. This is same for all three, right? Okay, hope you understood. Okay, keep studying. Okay, bye, take care.